what is scientific notation? Scientific notation is, let's say, a number written like this. So let's say 3.5 times 10 to the third, or another number would be, say, 4.1 times 10 to the negative 2. So these would be examples of numbers in scientific notation. So you might be wondering, well, what's the point? I mean, isn't it a lot easier just to write like 3,500? Like, why would we want to write numbers like this when it's a lot easier just to write numbers how we're kind of used to seeing them, like this? Well, let's say we have this number, 0.000000000, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 175 meters. So this is the nucleus of, or the radius of a nucleus. Well, this number is kind of hard to write. Like, we don't want to be writing all these zeros. Let's say we have this number. So 1, 1, 2, 3, 2, 3, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 kilometers. So this is the distance across the Milky Way galaxy. So if you went from one side of the Milky Way galaxy to the other side, this is the distance in kilometers. So this is the distance across Milky Way galaxy. Well, what about this number? So 0.7275 meters. So this number is the size of a water molecule. So size of water, which is H2O molecule. So you can kind of see that when we have really, like, this is a really small number, or a really large number, and this is another example of a really small number, it becomes difficult to write these numbers in the notation that we're used to seeing, like this. And so scientific notation is specifically so we can write really small numbers and really large numbers. And this is important for chemistry and other fields of science because we deal with really small numbers and really large numbers all the time, and you can see that writing these numbers out can become problematic, and putting them into your calculator, you're more likely to make an error. So scientific notation is specifically to write these numbers. So then the next question is, well, how do we write these numbers in scientific notation? So I'm going to do this first. I'm going to do these three, but I'll start with the first one. So starting with this one, what we want to do is start at the decimal point. So in this case, this number, where we want to move to the right. So we start at the decimal point and then just basically move the decimal point over. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I moved the decimal point 15 places. So I moved the decimal point to put it between the 1.75. I moved it 15 places to the right, so times 10 to the negative 15. And this number is in meters. So this, you can kind of check this because this is a really small number here, like 0.00000000175. And so over here, when we've written it in scientific notation, we have the 1.75 times 10 to the negative 15. And if we're basically multiplying it by 10 to the negative 15, and so that this negative 15 indicates that this is a really small number. So let's do this next one. So this number, we don't actually have a decimal point written in this number, so I'm going to go ahead and write one at the end. So is that on the camera? There. So I put a decimal point at the end of this number, and I want to go ahead and move it to here. So I'm going to have 1.0 times 10 to, and I need to figure out what this is, what the exponent is. So this number up here is called the exponent for the numbers in scientific notation. I'm going to take this decimal point and move it to here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I moved this decimal point 18 places to the left, and so this time this is going to be a positive 18, or positive exponent. So this number here, the exponent, will be positive when I'm moving the decimal point this way. And this makes sense because this is 10 to the 18th power. So that's going to be a pretty large number, and this is a very large number here. So that's one way to check to see if you are using the right the right exponent as far as positive or negative. So let's do this one now. This is, once again, this one we're moving the decimal point to the right, and I want to put it between the 2 and the 7.5. So I want my final number to be 2.75 times 10 to something. And so what I'm doing is figuring out what this exponent is. So I'm going to take the decimal point and just move it. So 1, 2, 3, 4, 5, 6, 7, 8. So I've moved the decimal point 8 places to the right, and so this is going to be -8. So 2.75 times 10 to the -8. And I want to go back and put units on these. So this one was 1.0 times 10 to the 18. Remember, this number was the distance across the Milky Way galaxy, and it was in kilometers. So I want to put kilometers on this number. So this is the unit. So meters, kilometers, and then this one is meters. So the units on these are meters, meters, and kilometers. So this one, 2.75 times 10 to the -8 meters. Now I want to give you some numbers to practice, and it might be helpful to pause the video and then come back and I'll go through the solutions. So 0.00015, 32 or 320,000, 64,000, 0.000621. So go ahead and pause the video and put these numbers into scientific notation on your own, and then unpause the video and we'll go through them. Now I want to go through these. So this one, we want to move the decimal point between the 1 and the 5 to put this in scientific notation. So I'm just going to write the 1.5 times 10 to, and then I need to figure out what the exponent is on this number. So I want to move the decimal, so I want to take the decimal and just move it over to here. So that's going to be 1, 2, 3, 4. And I moved the decimal to the right, so the exponent will be negative. So this is 1.5 times 10 to the -4 is equal to this number. Now let's do the next one. So this number, 320,000, this doesn't have a decimal point already, so I'm going to add one just so I have a decimal point to move. And I want the decimal point to end up between the 3 and the 2. So I'm going to just write down 3.2 times 10, and then I need to figure out what this exponent is. So I'm going to move the decimal point to the left between the 3 and the 2. So I have 1, 2, 3, 4, 5. So So that means my exponent, I moved the decimal to the left, so my exponent will be positive for this number. So this is 3.2 times 10 to the 5th. Now let's do the next one. This number, 64,000, also doesn't already have a decimal point here, so I'm going to add one. And then I'm going to, I want the decimal point to end up between the 6 and the 4, so I'm going to just write 6.4 times 10, and then I need to figure out what this exponent is. So I'm going to move the decimal point to the left, so 1, 2, 3, 4. So that means my exponent for this number is positive 4 because I moved the decimal point to the left. Now I'm going to do this last one. So this one already has a decimal point, and I'm moving it to the right, which means that the exponent for this number will be negative. And I want to move the decimal point so it ends up between the 6 and the 2. So I'm going to write down 6.21 times 10, and then I need to figure out what the exponent is. So I'm going to do that by just taking this decimal point and moving it 1, 2, 3, 4. So this is 6.21 times 10 to the negative 4.